All right, let's dive right in. Today, we're talking about something absolutely fundamental: human reproduction. Think of this as a guided tour of the incredible, intricate biological machinery that creates us. Ready? Let's go.
So what is it that makes human reproduction so, unique? Especially when you look across the whole animal kingdom. It really all comes down to one key biological strategy.
And that word is viviparous. Sounds a bit technical, right? But all it means is that we give birth to live young. Unlike, say, a bird or a reptile that lays eggs, humans develop their babies inside the body. This whole idea of internal development, that's the absolute foundation of our reproductive story. Okay, so here's the game plan for our tour. First, we'll get the big picture overview. Then we'll zoom in on the male system, the testes and the sperm's journey out. After that, we'll switch gears to the female system and the ovaries. And finally, we'll look at the path to fertilization. Simple as that.
All right, first stop, the 30,000-foot view. You've got to understand that human reproduction isn't just one single event. It's more like a cascade, a perfectly timed, beautifully choreographed dance where every single step has to happen in just the right order.
So, here are the major milestones on that journey, and it all really kicks into gear after puberty. First up, you have gametogenesis. That's just a fancy term for creating the essential cells, sperm and the ovum. Next is insemination, getting the sperm to where it needs to go. Then, the magic moment, fertilization, when they fuse to create a zygote. But it's not over. That new life has to implant in the uterine wall. From there, it's all about gestation. That's the whole development phase, and it all leads up to the grand finale, parturition, the delivery of the baby. What a process.
Okay, let's kick off our first deep dive. We're heading into the male reproductive system, and we're going straight to the heart of it all, the sperm production factory, the testes.
Now, the very first thing you'll probably notice when you look at a diagram like this is, the location of the testes. It's a bit odd, right? Unlike almost every other major organ, they're not tucked away safely inside the body. They're outside, in a pouch called the scrotum. And trust me, that is not a design flaw. It's an absolutely critical feature.
So, of course, that begs the question, why? Why on earth would these vital organs be located outside the main body? The whole reason comes down to a very, very specific number.
2.5 degrees Celsius. That's the magic number. The scrotum is basically a natural climate control system, and its whole job is to keep the testes about 2 to 2.5 degrees cooler than your core body temperature.
And why does that matter? Well, this is a classic case of form following function. That slightly cooler temperature is non-negotiable for spermatogenesis, the actual process of making sperm. If things get too warm, the whole production line can grind to a halt. It's that sensitive.
Okay, so we know why they're outside. Now let's pop the hood and look inside the factory itself. When you look at a cross-section like this, you can see it's not just a blob. It's this incredibly organized, dense structure, packed with hundreds of tiny compartments and coiled-up tubes. And every little piece in here has a super specific job. You've got about 250 little compartments, or lobules. Inside those, you find the seminiferous tubules. Think of these as the actual assembly lines where the sperm are built. But they don't work alone. You have Sertoli cells, which are like the support staff, providing nutrition. And then you have Leydig cells, which are like the factory managers, pumping out hormones like testosterone to keep the whole operation running.
All right, so the factory has done its job, the sperm are made. But they can't just hang out there forever, right? They need to get out. And to do that, they have to travel along what is basically a super complex highway system. Let's follow the route. They start on the assembly line, the seminiferous tubules, then they merge onto a network of smaller roads called the rete testes and vasa efferentia. All that leads to the epididymis. Think of this as a rest stop or a training ground. It's a long, coiled tube where they mature and get ready for the big trip. When it's go time, they shoot up the main highway, the vas deferens, and eventually merge into the final exit route, the urethra.
But here's the thing. The sperm don't make this journey alone. No way. For such a long and frankly dangerous trip, they need a support crew. They need fuel, protection, and a fluid to travel in.
And that support comes from these accessory glands. You've got the seminal vesicles, which pack the lunchbox, providing fructose for energy. Then there's the prostate gland, which adds an alkaline fluid. That's crucial because it neutralizes the acidic environment they'll encounter. And finally, the bulbourethral glands provide lubrication for the journey. All those secretions mixed together with the sperm, that's what we call semen.
So with all this intricate preparation, this whole factory and highway system, just how many travelers are we talking about? The number is, well, it's just staggering. We're talking up to 300 million.
Let's put that into perspective. In a single go, we're looking at anywhere from 200 to 300 million sperm. And for everything to be considered normal for fertility, at least 60% of those guys need to be properly shaped and good swimmers. It is absolutely a numbers game.
Okay, so we've got the sperm factory down and we've mapped out their exit route. But that is only, literally, half of the story. So now it's time to turn our attention to the other half of this incredible equation, the female reproductive system.
So here you can see the overall layout. Right in the middle, you have the uterus, and then flanking it on either side are the ovaries. And these small, almond-shaped organs, they are the source of the female gamete, the ovum, the egg. And the ovaries are real multitaskers. They have two absolutely critical jobs. Job number one, obviously, is to produce the ovum. But just as important, they're also major players in the hormone game. They secrete estrogen and progesterone, the hormones that basically run the entire show for the female reproductive cycle. Okay, so we have our two main characters, the sperm and the ovum. But they can't just magically find each other. They need a path. They need a meeting place. And that's where the female accessory ducts come in. They literally set the stage for fertilization.
This pathway starts with the fallopian tubes. This is the VIP lounge, the place where fertilization most often happens. From there, if all goes well, the fertilized egg travels to the uterus, or the womb. And what an amazing organ that is. It's designed to house and nurture a new life for months. And finally, you have the vagina, which serves a dual role as the canal that receives the sperm, and much later as the birth canal.
So there you have it. We've toured both sides. We have the male system, this incredible factory built for mass production and delivery, and we have the female system, perfectly designed to create the egg, provide the meeting place, and then nurture new life. All the components are in place, all the machinery is ready to go. Which leaves us with the one big, ultimate question: what actually happens when these two systems finally meet? Well, that is where the real story begins.